In this lesson, we're going to look at how we write ionic formulas. And the first thing we need to do is to understand what charge an ion has when that element becomes an ion. And we'll learn more about the reasons why it does what it does when we look at electron configurations. But for now, we're kind of just going to do a little bit of waving the magic wand and saying, hey, here's what the charges are. So for monatomic ions, so mono means one, so single atom ions, what we see is that we have this pattern for our main group elements. Notice that the transition metals, everything in the middle is going to behave a little bit differently. You see there's multiple charges, and we'll talk more about that later, about how we deal with that. But right now we're just focusing on the main group elements, so the first 2 columns and the last 6 columns. So when we look at that first column, what we see is that it forms a +1 charge. Again, hydrogen's an oddball. It's got a -1 in there too. We don't see that very often. Just don't worry about that for now. And what we see is those atoms are going to lose a single electron. And you can think of it, they're trying to look like the nearest noble gas. So for example, if lithium loses an electron, it looks a lot like helium in terms of the number of electrons. So that's what every element is trying to do. For some, it means losing electrons. For some, it means gaining electrons. For that first column, they're all going to lose 1 electron. They're all going to have a +1 charge. We go to the second column, our alkaline earth metals. We're going to see they all form a +2 charge when they form an ion. And then the third column here, again, we skipped over the transition metals. That third column, aluminum, has a +3. There's some other elements that can form ions. That's really the one we see most often. So we're just going to focus on that one. But the third column is going to form those +3. Notice we skip 4. You'll see the elements at the top are nonmetals. They tend not to form ions at all. Tin and lead, which are down near the bottom, can act more like transition metals than they do as a group 4. So those kind of fall under the transition metal rules. We're going to go over here to the far right, or almost to the far right, the halogen column. And what we see is that those have a -1 charge because they are 1 away from looking like the noble gas. So if they gain 1 more electron, they're going to have that same number of electrons as that noble gas. And those noble gases are the noble gases because they have a lot of stability. They don't react very stable. So that's why these elements will form ions that make them have the same number of electrons as the noble gas. So our halogens all give us a -1. Oxygen, sulfur, and selenium will give us a -2, and then nitrogen and phosphorus. And you kind of notice that where the metalloids are, that's where we stop talking about those ions because the metalloids tend not to form ionic compounds. So we can easily predict what charge things are going to take on based on their position in the periodic table for our main group elements. Transition elements, different ballgame, and we'll get to that later. The other type of ions that we see are polyatomic ions. So these are ions that are formed from a group of atoms, and they behave as a group, they act as a group, they're always together, and there's really no way around these except kind of memorizing them. This is a partial list. There is a full list on the Concepts to Memorize page that's posted on Canvas under Course Details, and so that has all the ones you need to know. But they have a specific name and a specific formula. For example, cyanide is Cn-. It's always going to be Cn-. It will not change. We do see that there can be some variations. For example, we see sulfate has SO4 2-. You'll also see sulfite in your list, which is SO3 2-, and hyposulfite. So you will see some variations even with the same elements forming different polyatomic ions. And they will always stay as that group, act as a group. The charge belongs to the whole group, not to any one atom within that group. And again, there's no real way around it. It's just memorization. I know there's some songs on YouTube with mnemonics. There are Quizlets and making flashcards. Things like that are the way that people tend to learn those.